Hello guys, welcome once more to another video on our YouTube channel. So in this video we continue solving the physics questions that featured in the National Aptitude Examination into the first year of medical, odontostomatological and pharmaceutical training in Cameroon. So we are going to be solving question 23 from physics 2017. So the question reads, two charges Q and 3Q located at points A and B respectively are separated by a distance A greater than 0. At what distance measured from the point A is the electrostatic field 0? We have 5 options. Alright, so first of all we start by drawing the diagram, then applying the concept of when the electric field between two charges that are like charges is equal to 0. So I have my horizontal, I have my two charges. The first charge, it's placed at a point A and the charge is Q. The second charge is placed at a point B and the charge on it is 3Q. Now the distance that is separating the two charges is small a, and small a is greater than 0. Now we need to find at what distance, which is measured from the point A, is the electrostatic force, is the electrostatic field, that is the electric field between the two charges 0. So I'm just going to indicate that the setting point between the two charges is going to be the point O, and the distance from the charge placed at the point A to the point O is x. I need to find x. Alright, because we need to find at what distance measured from the point A is the E field between the two charges equal to 0. Now I perfectly deduce that the point where the electrostatic field is going to be 0 is going to be at a certain point between the two charges, because the two charges are like charges, Q and 3Q. If Q is negative, 3Q will also be negative, so they will have the same sign. So they are like charges. If Q is positive, 3Q will be positive as well, so they will have the same sign. So when they are like charges, the E field will be 0 at a certain point that is in between the two charges. But if they are unlike charges, then the E field will be 0 at a certain point out of that is at a certain point that is closer to the charge with the smaller value, okay, and not between, out of the line that is joining the two charges. So if the two charges were unlike charges, then definitely the E field is going to be 0 at a certain point out of this line, and that point is going to be closer to the charge that has a small charge on it, so it's going to be closer to Q. Alright, but since they have the same charges, since their charges have the same sign, then the electric field is going to be 0 at a point that is between the two charges, and this point is closer to the charge that has a small charge on it, which is Q. Alright, now let us define what it means by electric field strength or electrostatic field. So the electric field strength is actually defined as the force per unit charge. Okay, so E is equal to F over Q. And what is F? F is the electrostatic force between two charges. So the electrostatic force between two charges, let's just say if I want to find the electrostatic force between A and B, I'm going to have the electrostatic force between A and B to be equal to a constant. This constant is actually 1 over 4 pi epsilon 0, but I just decided to call it a constant. So K times the product of the charges of those charges divided by the square of the distance that is separating the two charges. In this case, the distance separating the two charges is A, so the square of the distance is A squared. So this defines the electrostatic force of repulsion, because they are like charges, so they are going to repel. So this is the electrostatic force of repulsion between the two charges. Now we are going to find the electric field strength at a point O. Okay, in fact, the electric field strength at a point O is supposed to be 0, and for it to be 0, it therefore means that if I place, remember that electric field strength is a force per unit charge, so we must have a charge which we call the test charge. So if I place a certain charge at a point Q, at a point O here, whose maybe the charge on that charge is Q. Now I'm going to find the electric field strength of A. Okay, I'm going to find the electric field strength of the charge at A due to the charge at O, and I'm also going to find the electric field strength of the charge at B due to the charge at O, and I equate together. Okay, so let us find the electric field strength of the charge at A due to the charge, due to our test charge that is going to be placed at a point O. So generally, all we need to do is we need to take the force between the two charges and we divide by, we need to take the force between the two charges and we divide it by the test charge. So the test charge is placed at Q. So in other words, we are saying that the electric field strength at a point A due to a test charge placed at a point O is just equal to K times QA over X squared. Your K, because your force has K. Now normally the force is K times the product of the charges, but since there is one of the charges in the denominator, is going to cancel out with its corresponding charge in the numerator, so we are just going to be left with QA. So we have K times QA over the distance that is separating the two charges is X, so we have to square that distance. Now our QA is equal to small q, so we have KQ over X squared. Now we are going to find the electric field strength at a point B due to the very test charge that we place at O. So we are just going to have KQB, because normally it's going to be the force is KQ times QB over the square of the distance separating them. Then again we have to divide by Q, because electric field strength is force per unit charge. Okay, so once we divide by Q, the Q that is in the denominator here cancels with the Q in the force. We are just going to be left with QB, like I explained earlier. So we are going to have KQB over what is the distance separating the test charge placed at O to the charge placed at B. It is simply A minus X. Alright, so if we need to get this distance, we have to take this distance A here minus this distance X. Then we have to square the distance. But our QB is equal to 3 times small q. So with this, we have 3 KQ over A minus X all squared. Now let's dive into the concept. So the electric field strength at a point O is 0, provided the change in electric field strength of A and B due to a charge that is placed at O is equal to 0, specifically their magnitude, so that if it is negative, you neglect the negative sign. So in other words, we are saying that the electric field strength at a point A due to the charge placed at O is equal to the electric field strength at a point B due to the charge placed at O. So what is the electric field strength at a point A due to the charge placed at O? It is KQ on X squared. Same thing for the electric field strength of the charge B due to the charge placed at O. 3 KQ on A minus X all squared. Now we have to cross multiply. We have A minus X all squared times KQ. Then we have 3 KQ times X squared. On the two sides, we have like terms, KQ and KQ. Since they can't be 0, we can divide both sides by KQ. If we divide both sides by KQ, we are just going to be left with A minus X all squared equal to 3x squared. Now we have to take the square root on both sides. So basically, we are going to have A minus X to be equal to plus or minus 3 times, plus or minus the square root of 3 times X. But now A minus X is positive, right? Because A is bigger than X. So we are going to neglect the negative square root. We just have the positive square root. So A minus X will be equal to the square root of 3 times the square root of x squared, which is x, since x is a distance. So a minus x will be equal to x times the square root of 3. Since we need x, we add x on both sides, then we factorize x on the right hand side. We divide both sides by its coefficient, and then we have our x to be equal to a over 1 plus the square root of 3. So in conclusion, we are saying that the electric field is 0 at a certain point, that is at a distance of a over 1 plus root 3 from the point from the charge placed at a point A. So if you look at the options, option C is going to be correct. Thank you guys for watching. If you have any question, make sure you indicate in the comment section. If you love the video, like the video and subscribe to the channel. See you guys in the next video.